Hello everybody, it's Mrs. Duncan again. Welcome back for another very exciting edition of Online Chemistry. Today basically we're going to be talking about a laboratory technique which is called titration, and then a mathematical calculation that goes along with that. So I am begging you, please watch this video to the end. The Let's Practice problems will help you when you get to the assignment portion. Like I promised last time, I'm going to try to keep this short and sweet, so I am going to get right into it. When I say short and sweet, as short as possible. This might take me a couple minutes. Bear with me. All right, so before we get into what titration actually is, I want to go over something, and that is the difference between what is called a monoprotic and polyprotic acid. And then we'll talk about bases that are similar. So mono means one, poly means many. Monoprotic acids are ones that when you put them in solution, they dissociate into just one H plus ion. So what I'm saying here is HCl is a monoprotic acid because when I put it in solution, it produces just one H plus ion per HCl molecule. These two are going to be referred to as polyprotic. Again, poly means many. The reason why is when you put these guys in solution, notice there are 2 hydrogens here and 3 hydrogens here. These produce multiple or many, that's the word poly, hydrogen ions. So this H2SO4, when you put it in solution, it breaks up into 2 H pluses and 1 SO4 minus ion. This guy down here, this H3PO4, which is phosphoric acid, is also polyprotic because it produces 3 hydrogen ions in solution. So polyprotic, look for acids with more than one H. Monoprotic, look for something like this, where there's only one hydrogen in the acid's formula. There are monoprotic and polyprotic bases, and basically it comes from the fact that the bases act as proton or hydrogen acceptors during neutralization reactions. So that's something I should probably mention. A hydrogen ion, this guy is actually a proton. That's all it is. So basically when you say you have a monoprotic base, that means that when you put that in water, it dissociates into just one OH minus ion along with some other positive ion. In this case, it would be sodium. And that hydroxide ion here would take on the H plus to make a neutral product. So this is a monoprotic base because it only makes one OH in solution that accepts one H plus. You guessed it, these both are polyprotic bases. The reason why is they have more than one hydroxide ion as part of their structure. MgOH2 would make 2 OH ions in solution, whereas AlOH3 would produce 3 hydroxide ions in solution. This is going to be important later. Just make sure you keep track of what is a monoprotic acid and base versus a polyprotic. Okay, so what's titration? Titration is this laboratory technique. If we were together in class, we would do this and you would hate me for it because it is so tedious. But it's important because it helps us determine the concentration or molarity, remember that, of an unknown acid or base. So let's say I have an acid in this flask and I do not know the concentration of this acid. Is it a strong acid? Is it a weak acid? I don't know. I've got to figure out its molarity. Here's how this technique works. You have, in this case, if this is an acid of unknown concentration, this thingy here, this tall skinny tube, is called a burette. You would put a base of known concentration in that burette, so a base you know the molarity of, and using this stopcock here, you would drip by drip by drip add the base until the acid was neutralized. And based on data you collect during this experiment, you can ultimately calculate, which is where we're going next, the concentration of this acid. Real quick, how are you going to know when this acid is neutralized? Well, you're going to use an acid-base indicator. A common one used is phenolphthalein. Why? It is clear in acidic solutions, hot pink in basic solutions, and when the pH is 7, this takes on like a really light pink color. Why I said you would hate to do this in person is if you add one extra drop of base to that neutral solution, the whole thing turns hot pink and you have to start over. Okay, so while you're doing this titration, you need to keep track of a couple of things. The molarity of the known, okay? What's the molarity or the concentration of whatever you have in the burette? The volume of the unknown. So how much liquid unknown is in this flask? Is it 10 mils? Is it 20 mils? That matters. And then also, lastly, the volume of the known used to neutralize this, the solution in the flask. So basically, how much of this stuff, like 10 mils, 20 mils, 30 mils, how much of the known substance did you have to use to neutralize the unknown? All right, so there is an equation. Once you have all of those variables figured out, you've done the titration, your solution is now neutral. This is on the back of your reference table. It's called MAVA by chemists. Why? This looks like MAVA. It's MAVA equals MBVB, the molarity or concentration of the acid times the volume of the acid. So it's concentration times how much of it you have equals the molarity of the base times the volume of the base. So that is the general equation we will be working with. Again, this is on the back of your reference table, so you can always look it up if you forget it. The variables are defined right here. Okay, so here we go. We are going to go through 3 practice problems right now, and I'm going to tell you they are going to go pretty quickly from pretty straightforward to a little bit more complex. So if you are struggling, you may want to come back and view this video again, especially when you get to the practice assignment. Okay, so here's my approach. I look at these problems and I identify the formulas I'm given, because what I really want to do here is I want to differentiate between what is acid data and what is base data. So what I could do is this. I could say HCl, that is my acid. NaOH, that is the formula for my base. So the information that comes before my acid, if 25 milliliters, that's a volume of my acid of 2 molar HCl, that's my molarity or concentration of my acid. If 25 milliliters of 2 molar HCl is used to titrate 40 milliliters of NaOH, which is my base, this is the volume of my base. I want to know what is the concentration of the NaOH. What is the molarity of that base? Okay, so you're going to use the titration formula. And in this case, it's going to be pretty much a straight plug-in. MAVA equals MBVB. Why is it a straight plug-in? Remember those mono and polyprotic acids and bases we talked about? This guy is a monoprotic acid. This guy is a monoprotic base. The number of H's from the acid are directly canceled out by the number of OH's from the base. If that's the case, they're both monoprotic, you just plug right in. The molarity of the acid I gave you was 2 molar. The volume of the acid was 25 milliliters. You're supposed to find the molarity of the base. You can make that an X in your equation if you want. And the volume of the base used was 40 milliliters. You would have to simplify and solve. You would get 50 equals MB times 40. Divide both sides by 40. The molarity of your base is equal to 1.25 molar right here. Okay, so this is a straight plug-in because both the acid and the base are monoprotic. This is going to be a different scenario. Again, technique. Look at it to figure out where your acid and your base are. What volume of 2 molar NaOH is a base? So this is my molarity of my base. That is the concentration of my base. They want to know the volume of this 2 molar base, so I must be looking for the volume of the base, which is VB. So what volume of 2 molar NaOH should be used to neutralize 15 milliliters of 3 molar H2SO4? This is my acid. This is my molarity or concentration of my acid, and this is the volume of the acid used. This is not going to be a straight plug-in. Why? The base is monoprotic. That's good. There's just one OH here. The acid is not. It's polyprotic. There's 2 H's there. So here's what you're going to do. You are still going to use MAVA. MAVA equals MBVB. But because the acid has 2 H's for every one OH in the base, you need to multiply the acid side of the equation by 2. So I'm multiplying this, the acid side of the equation, by 2 because there's 2 hydrogen ions in that formula. From there, you proceed as we just saw. The molarity of the acid was 3 molar. The volume of the acid right here was 15 milliliters. The molarity of the base I was given is 2 molar. Oops, that's a 2. And the volume of the base is what I am looking for. So I'm trying to find VB. And again, you can make that an X. You would just need to simplify and solve. 3 times 2 times 15 is 90. Whoops. And that is equal to 2 times VB. Divide both sides by 2. The volume of the base used to neutralize that acid was 45 milliliters. All right, last one, because I'm almost out of time. This is about as hard as they get here, everybody. Neither the base nor the acid are monoprotic. How many milliliters of 3 molar H3PO4? That is my acid. This is the 3 molar. This is my concentration of my acid. This is my MA. I want to know how many milliliters of this acid are being used. So I'm going to be looking for VA. How many milliliters of 3 molar H3PO4 are required to exactly neutralize 150 milliliters of 1 molar CaOH2? That is my base. This is my concentration or molarity of my base, and this is the volume of my base. I am going to use MAVA, MAVA equals MABA, but I have to check my acid and my base. There are 3 H's in my acid and 2 OH's in my base. That means I need to multiply the acid side of the equation by 3. The molarity of the acid was 3 molar. The volume of the acid is what we're looking for. I have to multiply the base side of the equation by 2. Why? There's 2 hydroxide ions here. So 2 times the molarity of the base, which was just 1, times the volume of the base added, which is 150. Okay, so basically right here, you're going to have to simplify and solve. You're going to get 9 times VA equals, that's 300. If you take 300 and you divide it by 9, the volume of the acid used is 33 repeating. That's 33.33 repeating milliliters. Okay, that's about it. That's the idea. I would really strongly recommend perhaps watching that last part with the sample calculations a couple times because they can be tricky. And if you want additional practice, let me know. I can send you a practice worksheet. All right, good luck. Let me know if you have questions. I can help. Talk to you soon, hopefully. Bye.